In this video, we're going to go ahead and talk about exponents. And more specifically, we're going to talk about a few of the exponent rules. And then we're going to break down a couple example problems working with exponents and how to simplify expressions which contain exponents. So let's get started with our first rule. So our first rule is, what do we do when we multiply monomials? So this is called the product rule. I don't know why I don't have it down here, but this is the product rule. And the product rule states that when you are multiplying two or more terms which have the same base, and the base is the larger number or variable on the bottom, then we're going to go ahead and just add the exponents. So let's look at our first example. So here we have n to the 6th times n to the 4th times n to the 1st power. Do you guys remember that? Maybe, maybe not. That's why it's always good to review, right? Okay, so if there's no exponent, we just put in a divisible one. Now notice that we are multiplying the bases, or the n's. The n's would be the bases, and the exponents would be 6, 4, and 1. So the product rule says, okay, if all the bases are the same, let's go ahead and keep that common base and just add our exponents. So 6 plus 4 plus 1, that's going to simplify down to n to the 11th. So we can just combine it all that way. So that's your product rule. Let's look at our quotient rule next. So quotient just means division. It's a fancy word for division. Use that one at home, right? Okay, so when you are dividing two monomials with the same base, what we're going to do is we're going to go ahead and subtract the exponents. So when we were multiplying, we were adding them, right? So when we're dividing, we're going to actually subtract. Kind of the opposite operations if you really think about it. So let's break this one down step by step. So the first thing we notice is we are dividing two monomials, okay? And we're going to start with the coefficients. Now the coefficients are the number outside, or I'm sorry, being multiplied by the variables. And here we see the coefficients are 8 and 16. Notice that there are no exponents attached to those coefficients. It's 8 to the 1st, essentially, right? So, and 16 to the 1st. So we don't have to worry about exponent rules. We can just treat that as 8 over 16. Well, if you remember, 8 over 16 is going to just simplify down into 1/2, because the top and bottom are divisible by 8 each. So we can actually simplify that whole thing down to 1/2, or 1 over 2. And we'll see that we don't have to put the 1 there, but for now, that's okay. Now, we want to pick the monomials which have the same base, so the same exponent as a base. So we see a's, there's two a's here, a to the 5th and a to the 3rd. Well, since we are dividing those bases, we can go ahead and take those exponents and just subtract them. So 5 minus 3 is going to get us 2. So a to the 2nd power, because that would be 5 over 3. You can also think of it as a to the 5th. There's 5 a's on top. 4, 5, and then a to the 3rd. 1, 2, 3. How many a's do we cancel? Boop, boop, ba-doop. 3. And that means that a squared is left on the top. So that's another way to think about it if you write it out the longhand way. And then last but not least, let's go ahead and combine those b's. Now, when you're combining those b's, they have the same base, so we can just subtract the exponent. So 4 minus 7 is going to get you -3. So we could go ahead and say this is b to the -3. But if you've been working with exponents, you may realize that negative just doesn't work. We don't like negative exponents in algebra, or just as mathematicians in general. We go, they suck, we don't want them. Okay, so we write them a different way. Let's think about it a different way. We have 4 b's on top and 7 b's on bottom. Well, if we cancel 4 of those b's on top and 4 of the b's on the bottom, where are the b's left? Well, the b's are left on the bottom. And in fact, there's going to be 3 b's left on the bottom after you simplify. So this is actually going to turn into 1/2 b to the third on the bottom and a squared on top. Now, I don't need to write that 1 up front because you're multiplying by 1, so it doesn't really matter. I just like to put it there as a placeholder in case everything else cancels. Okay, so a squared over 2b to the third. Okay, so these are actually the same concepts. If you have a negative exponent, to make it positive, or I like to say to make it happy, just switch the side that it's currently on. So b to the negative third, it's not happy, it has a negative exponent. So to make it happy, let's flip it to the bottom, and suddenly he's happy. Yay! So easy to make somebody happy. Who knew? Okay. Now, so we just talked about negative exponents aren't allowed, and you just move it to the opposite side. Let's go ahead and do one more practice problem where we have negative 9x y to the fourth z to the negative second, 3x cubed y to the sixth z to the second. Whew. That's a lot going on there. So where do we even start? Usually that's the question that I get asked the most. Where do I start? Well, when you're looking at this, you can approach it a couple different ways. Usually if there's parentheses, I encourage you to get rid of parentheses first. Luckily for us, there's no parentheses here, so we can just go ahead and dive right in. So I like to start with our coefficients. Our coefficients are -9 and 3. Remember, coefficients, they don't have those exponents, or they just have an exponent of 1 if you want to think of it that way. So -9 divided by 3 is going to be -3. Woo. And that's going to be on top. And we have x over x cubed. Now, what is that exponent on x? Well, that exponent is going to be, hopefully you already said it out loud, x to the first power. Remember, no exponents, really exponent of 1. So x to the first over x cubed. Now, I like to take a moment here and just look at it and go, okay, well, where are most of the x's going to be? There's 1 x on top, 3 x's on bottom. The majority of x's are on the bottom, so that means when I subtract it, 1 minus 3 gets me -2. Well, x to the -2 isn't really what we want, right? Because we just learned we can't have those negative exponents. He's not happy. So let's go ahead and delete that and instead write x squared on the bottom. So generally what I do is I say there's 3 on the bottom, 1 on the top, subtract the 2, 3 minus 1 would be 2, and that would mean that it's on the bottom since there's more x's there. So that's just kind of a faster way to do it, if you want to think of it that way. Now let's move on to y's. Remember, we're concentrating on the same base here. Y to the fourth over y to the sixth. Where are most of the y's at? Well, they're on the bottom, right? Y to the sixth is on the bottom. It has 2 more y's than on the top. So 4 are going to cancel on the top, 4 on the bottom. So you're left with y squared on the bottom. And now we have our last monomial z squared and z to the negative second. Now, this one's a little bit different. You may be going, I don't like that negative exponent. So there's 2 ways to handle it. Okay. The first way is saying this z up here, he's not happy. Okay. Not happy with his life right now. So to make him happy, we can flip him to the bottom. So we already have a z squared down there, but if we move that z to the -2 down to the bottom, it makes him happy. And you may notice now I have two z's which are being multiplied on the bottom. So to combine them, I can go ahead and just add it. So this becomes negative 3 over x squared, y squared, z to the fourth. I just added those exponents together. That's the product rule in action. So this would be our final answer. Now, that was one of the ways. Okay. The other way is to say, okay, z to the negative 2 over z squared. Let's use that quotient rule and just subtract them. So it would be z to the negative 2 minus 2, which gives you z to the negative fourth. Well, that negative always jumps right to the top. So if he's not happy on the top because he's got that negative exponent, let's go ahead and just bring him right to the bottom and make him happy. Yay, he's happy on the bottom. There we go. So z to the fourth. So that would be your other way of doing it. Pick the way that you're most comfortable with. Especially with exponents, you can usually do them out of order and you're generally okay as long as you're dealing with the parentheses first. So that was your brief review of exponents. Remember to study those rules a little bit more, and good luck.